let's talk about universal and existential quantifiers. Quantified statements, universal and existential quantifiers. Very good. So suppose you have a predicate with domain D. Let Px be a predicate. Again, you have a statement with some variables. Px be a predicate with domain D. A universal statement is a statement that written this way. For all, for any, this is your universal quantifier for all. X in domain D, you have P of X. An existential quantifier gives you an existential statement. So you have a statement with existential quantifier that is written this way. There exists some values in domain D such that P of X. So universal quantifier for all, for any. Existential quantifier, there exists. Universal quantifier, existential quantifier. We say that a universal statement is true if the predicate is true for every element in D. An existential statement is true if and only if you can find one value in your domain that makes the predicate to be true. For example, let's take a look at the following. Truth and falsity of a universal statement. Consider the following domain. Suppose domain D be the set including 1, 2, 3, 4, and 5. And your universal statement is written as for every x in domain D, x squared is larger than or equals to x. Okay. Question says, is this a true statement? Well, a universal statement, we know that a universal statement is true if and only if it is true for every element in the domain. Okay, take a look at this. This is my domain. I gave you the domain, which includes just finite numbers of values, 1, 2, 3, 4, 5. I'm going to plug those in to the statement here and check to see if this is true for every member here. Take a look. 1 squared is larger than equals to 1, of course. What about 2? 2 squared is larger than equals to 2, of course. What about 3? 3 squared is larger than equals to 3, of course. What about 4? 4 squared is larger than equals to 4. 5, yes, the same. 5 squared is larger than equals to 5. So what is our conclusion? Our conclusion is that the universal statement is true on the given domain. Guys, make sure you're mentioning the domain. The domain is super important for us. So this is our conclusion. The universal statement is true on the given domain. Very good. What if I change the domain? Now, suppose I'm working with the domain to be R, all real numbers with the same universal statement. For every x in D, I'm going to say that, hey, x squared is larger than equals to x. Okay. Is this a true statement? Of course not. We can find counterexample. Since we can find one, just one, guys, one counter example, like what? Like x equals to a half. This makes the universal statement not true. So, to show that a universal statement is true, you need to check for each member. To show that a universal statement is false, you only need one example that make the statement to be false.